Integration involving inverse trigonometric functions. The title of this section is a bit misleading. It sounds as if we're going to learn how to take integrals of expressions that contain the inverse trigonometric functions, when in fact we're going to integrate expressions that result in answers that contain the inverse trig functions. The good news is that there are only three forms with which we must concern ourselves. So if you remember from our derivative units, what we had is if we had arc sine of x and we took its derivative, it was 1 over the square root of 1 minus x squared. When I had arc tangent x, or inverse tangent, and I took its derivative, it was 1 over 1 plus x squared. And then when I had arc secant, absolute value of x, its derivative was 1 over x times the square root of x squared minus 1. And then what I have on the right side are the u substitution forms. And I did post the proof of the arc sine on Canvas. I posted that proof for those of you that would like to see it. It's very, very high level proof. And one of the proofs uses something called integration by parts, and we don't do that in AB. That is a BC topic, so it's beyond the scope of our course. So here we go. And again, just do your best to stay with me on this. This is going to go high level. If I have the integral of dx over the square root of 4 minus x squared. So I want to look back at my three options. And do you see that this best looks like the du over the square root of a squared minus u squared? So we want to keep that blue box nearby. So what is a here? 2. And my u is the x. The du is dx. So then, when I go to integrate this, it's arc sine. My u is x. My a is 2 plus c. So this is just one you sort of just have to memorize it. So then let's look at this middle one. This one looks like the du over a squared plus u squared is 1 over a arc tan u over a plus c. And I like to write them out a few times because I need to tell you I have to re-memorize these every year. They're just done rarely. So even as a 31-year math teacher, I still, because it comes up so rarely, I have to re-memorize it every year. So when I'm looking at this one's a little bit trickier. So do you understand that the a squared is 2? So what is a? Square root of 2. If my u squared is 9x squared, what's my u? 3x. So then when I go to do my du, I get 3dx. So then that's where I'm going to get this 1/3 du equals dx. So I've really got 1/3 the integral of du over my a squared plus u squared. So then according to that formula, I've got 1 over a arc tan. My u is 3x over my A plus C. And we can just cut our losses and do that one. All right, now that I've done part A and part B with you, I want to pause and give you maybe 2 minutes to try letter C. This one, of course, is going to be the third one. Try to recognize what A is, what B is. And do you understand why I have this extra 1/3? Does that make sense where that 1/3 came from? Good, good. Okay. So try the third one. Thank you. All right, are you getting that A is 3 and U is 2x? So then I'm going to have this 1/2 the integral du. Now we have a problem here, don't we? Did you catch this? That this is an x, but I have a u that is 2x. So what do I have to do? I'm not actually going to put u here. What do I have to put? U over 2. Nice work, nice work. So that's going to be a u over 2, the square root of u squared minus a squared. So do you see that? This is really tricky, really, really tricky. Because this is for u, but I don't have, this is not completely u. So I had to divide by that too. So what happens to the, you understand that if I flip that over, that would cancel with my 1/2 out front? We good with that? So then that's going to be du over u square root u squared minus a squared. So that's 1/3. Okay, so do you see that I have a fraction within my fraction here? So if I have the u over 2, that 2 you multiply by the reciprocal would end up being by 2 over 1. So it's going to cancel the 1/2 out front. So pretty tricky business here. Then I'm using this formula, and so that would be the absolute value of u, which is 2x, over my a, which is 3. So these are tough, okay? These are really, really tough. And I'm not sure how much time we want to expend our energy on for maybe one problem. I mean, it'll definitely be on the AP exam, multiple choice. We got to weigh that So we'll work on it. We will work on it. Okay, so what I said is on the quiz Tuesday, I'm not putting one of those three on there. This next part, the change of variable method, is. That will be on there. I don't want to have anybody confused. All right, so here is another type of problem we could run into. Although we will still use substitution, sometimes we have to use this method called change of variable. So in letter A, I have the integral of x times the square root of 2x minus 1 dx. So if I start with u is 2x minus 1, and I get du is 2 dx, do you see that I still have a problem? I have a problem with this x right here. This would be, I have my 1/2 out front, I'd have the square root of u du, but I have this x. I cannot do it in two variables, two different variables. And I cannot integrate it like this because 2x minus 1 to the 1/2 power times an x to the first, there's no simplification of that. So watch this. This is called the change of variable method. What if I add 1 to both sides and divide by 2? Watch what I can do. Then this is like super cool math. I'm going to rewrite my x as u plus 1 over 2 times the square root of u, and I have my 1/2. Don't lose that little 1/2. And you may be thinking, okay, well, why would you do that? Watch what happens. If I pull that other 2 out, change a variable, now I can do u times u to the 1/2 and 1 times u to the 1/2. I can't do that here because that's two things, it's a difference to a fractional exponent. So watch this. I can go, that's u to the 3/2 plus u to the 1/2 du. So let me kind of point this out because we've been battling this in my Algebra 2 class. 2x minus 1 to the 1/2, they keep trying to do this. And that's false. Like, you cannot do that. That is just not true. So now we know how to integrate this. So I'm going to increase the power by 1, divide by that new power, increase the power by 1, divide by that new power, and add my arbitrary constant c. We need to back substitute what u is. Oh yeah, sorry. Thank you. Yep, absolutely. So then that'll be what, 1/10, and then let's replace u with 2x minus 1 to the 5/2 plus 1/6, 2x minus 1 to the 3/2 plus c. And this is definitely on the exam, okay? This is definitely on the exam, and we definitely want to figure this one out. All right, I'm going to pause and let you try letter B. Any questions before you get started on the next one? Questions for clarification? All right, try B. Because right now, a u substitution won't work. While you're working the circuit Hopefully you got partway through. Is due on Monday. I'm going to change that to Monday because Monday you're going to do a review sheet. And I went ahead and posted my worked out solution, so if you get stuck, you can at least like figure that out, or if it's a little, because it's long, and if you just want to go down the page instead of circling through the circuits, then that's fine too. The circuit's just a fun way to do the same thing. Something else I want to mention while I'm trying to be patient is I posted this morning a exam prep folder, and I have put like 7 practice worksheets in there. I did look on the calendar, and we've got 12 weeks. We've got quite some time, but we are not going to have as much exam prep as I typically like. So that means you're going to be doing most of your exam prep on your own time, okay? So that means we're going to start now. And so what I did is I posted 7 different ones. Now, some of them I haven't gotten to unit 7 or 8. So when you hit a problem and it's asking you to do a volume of revolution and you have no idea what that is, then you stop. You don't do that one. Now, it doesn't mean you can't do the one after it. And then slope fields, we haven't gotten to slope fields, we haven't gotten to separation of variables, we haven't gotten to differential equations yet. So the first probably 3 or 4 worksheets, you can do all of those. Once you hit, I think, around the 5th one, that's where you're going to run into problems on it that you can't do. Then after probably 4 or 5 weeks, I will post the answers to those. But for now, I would like you to do some good, productive struggle. All right, so what did you allow u to be? X plus 4. So du is dx. So that's going to be great because that's going to make it the square root of u du. But then my problem is this 2x plus 1. So watch what I'm going to do. I'm going to subtract the 4. And then I can replace the x with u minus 4. So that'll be 2 times u minus 4 plus 1. So that's what, 2u minus 7 over u to the 1/2 du. Then I'm going to separate it. And make that 2u to the 1/2 minus 7u to the negative 1/2, that quantity du. Then I can integrate. So I increase the power by 1, divide by that new power. I increase the power by 1, divide by that new power. Don't forget your arbitrary constant c. So then we're going to back substitute and simplify. So I get 4/3 the quantity x plus 4 to the 3/2 power minus 14 x plus 4 to the 1/2 power plus c. Something I want to remind you of, these were indefinite integrals. An indefinite integral, again, is where you have an integral and there's no limits of integration and you have the arbitrary constant c. So now what we're going to do is we're going to move on to substitution with the definite integral. There are 2 ways that you can approach these, and I'm really going to go one way with you because they'll force it. They'll force it where you have to actually change your limits of integration. So look at example 9, letter A. What would you allow u to be here? X squared plus 1. Du is 2x dx. I scan through my problem and there's no 2. So I'm going to divide it out. And then watch what you have to do. This is what I'd like you to write down, is you are going to change the limits of integration. When you do u substitution in a definite integral, you need to change the limits of integration. How do you do that? You go to your u statement and you plug in the lower limit for x, and that becomes your new lower limit. So what's my new lower limit? I just heard it. 1. What would be my upper limit? 2. Then this is, I've got my 1/2 out front, u cubed du. So let me go through that one more time. When you have a definite integral and you use u substitution, you have to change your limits of integration. You go to your u statement, plug in x is the lower limit, 0 squared plus 1 is 1, 1 squared plus 1 is 2. So let's integrate. So I increase my power by 1, divide by my new power, and now I'm integrating from 1 to 2. So that's 1/8, 2 to the 4th, minus 1/8, 1 to the 4th. This would probably be a no calculator problem. So even though you could reduce 16/8, do you see the benefit of leaving the common denominator to subtract? All right, letter B. I'm going to let u be 2x minus 1. Du is 2 dx. I don't see a 2, so I'm going to divide it out. I'm going to change my limits of integration. I'm going to have to deal with that x up in the top, too. So we're putting it all together on this one. What would be my lower limit? It's actually 1, right? Because 2 times 1 is 2, so this stays 1. What's my upper limit? 9. So this is now going to go 1 to 9. Now, do you see I don't have an x anywhere? So I'm going to have to take this piece, add 1 and divide by 2 over the square root of u du. All right, so this is u plus 1 over 2 times 1 over u to the 1/2. When you divide by the square root of u, that's the same as multiplying by its reciprocal. I'm going to pull that other 2 out. And see if you can go with me. This will be u to the 1/2 plus u to the negative 1/2. du. Do you see how I simplified? Did my little algebra here? I pulled this 2, okay, I pulled this 2 out to make it 1/4. Then that would leave me, I skipped a step, u plus 1 over u to the 1/2. That's u over u to the 1/2 is u to the 1/2, and 1 over u to the 1/2 is negative u to the negative 1/2. All right, so this is a tough one here. So I'm going to increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power. And I'm going to do this from 1 to 9. Now you have 2 options here. you can either do the bracket and then take that answer times 1/4, or you can multiply through by 1/4 first and then do from 1 to 9. We're still going to get the same answer. So I'm going to pause and give you a quick head start on me and see if you can finish it. You choose which route you want to take. Now there is a second way to have done these but I try to not do it with students because the graders will ding you if you have incorrect notation and it's too easy to do incorrect notation. You could go through, do the integration like a indefinite and then put x back in and then do it from 0 to 1, but it's really tricky to make it equivalent that way. So we're just going to avoid it. All right. Whew. Okay, this is a tough one. Now, do you remember that the 3/2 power means take a square root of 9 is 3. 3 cubes, 27. 3 goes in there, 18. So 27 divided by 3 is 9 times 2 is 18. This one's 2 times the square root of 9, which is 6. Minus 2/3 minus 2. So I got 22 minus 2/3. I'm going to now multiply, I think, through by that 1/4. No, because you had that minus 2. Did you catch this minus 2? Here. So I'm getting 32 over 6, or 16/3. So that one was tough. That was a tough one. All right, here is a multiple choice style question. And this is how they like to get you so that you have to do the U substitution and you have to be able to change the limit. So we're just going to work it that way. And so I'm getting low on time with today being shorter period, so I am going to speed up a little bit. And if you need to, just watch this, whatever example you need from the video. Example 10 says, if the substitution u equals x over 2 is made, the integral from 2 to 4 of 1 minus x over 2 squared over x dx would equal which one? So let's think about this a moment. If I use u is x over 2, be careful, du is 1/2 dx. So then I'm going to have the 2 out front. This will be 1 minus u squared. And what are you going to do for the x that's in the bottom? Yes, it's going to be 2u du. And then what would be my new limits of integration? One and 2. So do you see, if I'm guessing, I can automatically eliminate letter B. I can also eliminate A because there's no 4u. But what they're Do you see what error they think you're going to make to have chosen letter C? Forgetting that that's a 2du. That's what they're banking on. So this should in fact be letter choice D. All right, example 11. The twice differentiable functions f and g are defined for all real numbers x. Values of f of x and g of x are in the table below. Evaluate from 0 to the integral 0 to 5 of g prime of f of x times f prime of x dx. So what they are trying to get you to realize is that if I let u be f of x, du is f prime of x dx. So they're trying, and this is not the only way to think of it, but I could let u be the inside function, then du is this f prime of x dx, but my limits of integration would change. And so if you look at my table, f of 0 is 1, f of 5 is 3. But what do we know about the integral of g prime? Just in general, what is the integral of g prime? G, right? So then this is going to be g of 3 minus g of 1. Well, then you're going to look at your table. G of 3 happens to be 3. G of 1 is 10. So that's negative 7. Say that again. No, because we have the f prime of x dx. So I let u, do you see I replaced that? Yeah. And then I took care of it by doing f of 0 to f of 5. Yeah. Okay. There are more trig functions that you can integrate. I'm actually only going to I'll do letter A, and if I have time after example 13, I'll come up back to B, because that one's just a doozy of a like, these are, I'm really proving them. So if I want to integrate the tangent x dx, so you do need to memorize these, or I can always figure them out. So watch this, and this ties in to our u substitution. So watch this, and again, I'm going to lead you through this quickly, and then you might need to go back through and think about it. If I let u be cosine x, du is negative sine x dx. You could not allow u to be sine x, because that would be 1 over the derivative, and I can't do 1 over. So that's why I have to choose u as cosine x and not u as sine x. So I don't have a negative, so I'm going to divide that out. So then this will be negative the integral 1 over u du. Oh, guess what? I know that one. That's going to be the negative natural log, the absolute value of u plus c. And do you see? Did it get cut off? So this is the one, the integral. Oh, it's on the next page, sorry. These are the ones we already knew. And then if you look, there's my tangent. Again, B is just a proof, and if I have time, I'll come back to it. If not, I'll write it up here and then upload it with the completed notes. But again, I don't memorize those. I can figure all of them out by a u substitution, okay? All right, then the last one, example 13, says evaluate the integral from 0 to pi over 4 from the square root of 1 plus tangent squared x dx. Ooh, ooh, ooh. Remember from pre-calc, you remember your Pythagorean identities, that sine squared x plus cosine squared x is 1. And I happen to know, and I don't memorize these, but I can figure them out. I can divide that Pythagorean identity by cosine squared x, and this produces the second Pythagorean identity. So make sure you do have this one, and then we can build the other two, okay, just by dividing by cosine squared x, or dividing by sine squared x gives you the third Pythagorean identity. So I'm not doing a u substitution at all. I'm going to do a Pythagorean identity substitution, and I'm going to replace 1 plus tangent squared x with secant squared x. Well, what do we know about the square root of a square? They cancel. And then I'm going to look up here at the top, and this one is the natural log of secant x plus tangent x, and I'm evaluating from 0 to pi over 4. So this would be the natural log, absolute value, secant pi over 4 plus tangent pi over 4 minus the natural log, secant 0 plus tangent 0. Oh, so we're going to need our unit circle. So the secant of pi over 4. So if you need a 45, 45 right triangle, 1, 1, square root 2, that's square root 2 plus 1. Secant 0 is 1. Tangent 0 is 0. Now, square root 2 plus 1 is positive. So that is the natural log of square root 2 plus 1. This would very likely be a no calculator problem. Again, I went